DuPre, we're going to talk about Wittgenstein versus Gödel.
Thank you for inviting me, Laura. I'm going to give this out to those of you who don't have them. If there are any logicians here, you probably won't be satisfied because I'm not giving that kind of talk. How many do we need there? How many more down there?
3.
You need one too, right? There you go. Okay, so the advertised subject of the talk are Wittgenstein's comments on Gödel's theory. And he made many comments, but the most notorious comments he made about Gödel were in this so-called notorious paragraph, which is in Appendix 1 of his book, the most mathematical one of all, that he wrote, Remarks on the Foundations of Mathematics. I first ran into this book when I was an undergraduate, and my advisor, math professor, whatever, suggested I take a look at Wittgenstein. So I did take a look at it. It was like total nonsense. I couldn't understand it. It didn't make any sense. As I got older, I saw the humor in it. And I'm going to start off talking about Wittgenstein's comments on Gödel and who's taking up for him and who's against him. But then I'm going to switch and show you as many as I can of the funny comments that Wittgenstein made. Has anybody read any of Wittgenstein? Anything? I did. You find him funny in some cases? Yeah. A sense of humor? Okay, I'm going to pick out as many of those things as I can and show you.
Unfortunately, not everybody knows who Wittgenstein was.
He was a philosopher, part of the Vienna Circle, which was Carnap, even.
Yeah, you have to say.
I'll name the wrong people.
It's considered the greatest philosopher of the 20th century. But since so few people know about philosophy, many people never heard of him.
Yes. The comments that he made, this notorious comment was, some people think he was trying to say Gödel's theorem was false, and he wasn't. What he was trying to say was that he had proved something, but he didn't realize what he had proved. And some people think, until you get into it more deeply, that the essence of Gödel's first incompleteness theorem, for example, which says that anything containing strong enough to do arithmetic always has undecidable statements in it. But he wasn't. What was true and what he saw and other people saw is the idea of having, you'd think that having a sentence that said of itself, I am unprovable, would be enough to have a true but unprovable statement. But you don't even need that. That's an informal interpretation of what this Gödel sentence says. It says something mathematically, but it never has to be translated into that colloquial English that says, I am unprovable. It's not necessary. So, when this came out, there was a guy, Stuart Shanker, I'm looking down here. Got lots of trouble. Go through this like crazy. Well, I have a thing I need at home. If I break it, I can't use it. He's the first one that took up for Wittgenstein and said, yes, he did understand Gödel. Some logicians said that this proves that he didn't understand what Gödel was saying. And he and I think he's at York in Ontario. I've never talked to him. I've never met him, never exchanged emails with him. And she's in Boston. And this isn't the same Putnam, I'm sure, that they named the Putnam exam after. Funny first name, right? And I'll read you a little bit about what they say in one of their papers about this controversy. I didn't read all these. I read all that again. There's one called Gödel's Theorem in Focus, which is a whole chapter on Wittgenstein's interpretation of that. This is called a note on Wittgenstein's notorious paragraph, in quotes, about the Gödel theorem. So, I think if I read this to you, I'll be reading a lot to you today. You know, hope you elicit at least one smile, if not a laugh, about some of the things that are said. Well, they put the paragraph right there. It says, we believe that the notorious paragraph contains a philosophical claim of great interest which has been almost entirely missed in the brouhaha about whether Ludwig Wittgenstein understood Gödel's theorem. This is what they describe in there. One of the things that he says has as consequence the fact that any model of the integers contains things that aren't integers. And that's actually independent of Gödel's theorem. But since our purpose here is to detach that claim, so to speak, from that disputed question, although the fact that Wittgenstein's critics seem to have missed it, surely must be relevant to this. Maybe there.
Do they actually say that any model of the integers contains things that are not integers, or is that?
No, that's not part of Gödel's theorem. That's somewhat irrelevant. It's not irrelevant to Gödel, but it actually was proved in 1934 by Scullin, I think, that statement that any model of the integers, this integers we're talking about, are going to have non-integers in them. But you can't capture the integers. That's what you want to do. You want to capture them. You don't want anything more or anything less. Unfortunately, that's not possible. It's called Scullin's theorem. I have this written down somewhere. What? But what are these non-integers anyway? What are they? It's like some Conway numbers? I don't know. But I want to mention a little bit of what they say. It said, the claim is simply this. If one assumes, and a fortiori, if one actually finds out that not P is provable in Russell's system, P is the statement, the Gödel statement, the Gödel sentence that says that can be interpreted as I am unprovable, but that's not part of the proof. You don't need that. But it still helps people to think about it, because then you can use it. If not P is provable in Russell's system, one should, or as Wittgenstein actually writes out, will now presumably give that interpretation up. That I am unprovable. And this isn't a long paper. It's a fairly short paper, even though there are some longer papers written by them. Some of the people that they argue with are, let's see. Well, I guess the next paper is the same subject by the same people, but it mentions this guy, Timothy Bayes, I think. Let's see. Bayes and Steiner. There were some people, I think, Kreisel, some other people came out really against Wittgenstein when this first came out. Those remarks were made in 1939, quite a long time ago.
So Wittgenstein critiqued Gödel shortly after Gödel, because Gödel was 1935. So Wittgenstein's critique?
31, I thought.
Oh, 31, right. So I'm curious. Right?
Right.
Yeah,
Did I say 35?
No, that's 31, right?
Yeah, it's 31.
Yeah.
These remarks are made around 35.
Yeah.
And the interesting thing is that in Wittgenstein's lectures at Cambridge, one of his students, and this is recorded, there's a book, not remarks on the foundations of math, but lectures on the foundations of math, has those lectures plus all the comments back and forth. And Turing was a contributor to that. And you can read Turing's comments in Wittgenstein, the back and forth, how Turing says, well, this, and he says, no. And Wittgenstein would indicate why he was misunderstanding things. Turing was. And the reason that Turing was attending Wittgenstein's lectures is because at that point he had a lot of respect from a lot of people, including people like Turing. So I want to read some things from here. I wrote out some of the more interesting comments. Yeah, this is just one. This is somewhat funny, but not really. It's something to think about. In fact, I've never read anything like Wittgenstein. Nothing. There's nothing even comes close. Have you seen anybody that writes like he does? Imagine set theory as having been invented by a satirist as a kind of parody on mathematics. Later, a reasonable meaning was seen in it, and it was incorporated into mathematics. Here's a parenthetical remark for it. If one person can see it as a paradise of mathematicians, and you knew who said that, right? Hilbert. Oh, no. Who did say that? It says, no one's going to kick us out of...
That was Hilbert.
It was Hilbert. No one is going to kick us out of the paradise that Hilbert has created.
Cantor
Cantor has created.
Hilbert said about Cantor.
This is about Cantor, too. Anyway, let me...
This is Wittgenstein's remarks?
Yes, this is the Wittgenstein. Okay, for if one person can see it as a paradise of mathematicians, why should not another see it as a joke? The question is, even as a joke, isn't it evidently mathematics? Okay, here's some other. These are. I'd like to read his original remarks, and I'll get to some of Juliet Floyd's. You cannot learn to view the geography of a landscape as a whole if you move on in it so slowly that you've already forgotten one bit when you get to another. This I like. We say, if you really follow the rules, a lot of his stuff was in what it meant to follow a rule. That's not as straightforward and easy as you think. It has to do with training, too. We say, if you really follow the rule in multiplying, you must all get the same result. Now, if this is only the somewhat hysterical way of putting things that you get in university talk, it need not interest us over much. He himself was an academician. The mathematical must concept is a vague concept. Yeah, this is also notorious, but it's not a part of the original paragraph. My task is not to talk about Gödel's proof, but to bypass it. Pretty negative thing to say, right? I'll read that later. Yeah, this is another idea of his. And I might have to go into it more to explain what he means by it. To him, he was seriously entertaining the idea that every proof is an experiment. Calculation. We'll do that first.
So it's good for
Every calculation is an experiment. We'll do that first. Then we'll talk about every proof is an experiment. What does that mean, every calculation is an experiment? Doesn't it either come out right or wrong? If it does come out one way and another way, you're experimenting to see how many people can get it right. In other words, you're saying you don't really know what the result is until you do it. So any result you get is a result. It's a different way of thinking about things. The proof is an experiment. It's a funny thing you said here. If a proof is considered as an experiment, at any rate, the result of this experiment is not what is called the result of the proof. The mathematician is an inventor, not a discoverer. That's a separate remark. Because he believes that mathematics is not discovered, but invented. Now, that has a lot to do with what's called Platonism now. A mathematical Platonist is someone who believes that the things out there are there independent of people. It's like if a tree falls in the forest, does it make a sound if there's nobody to hear it? And Wittgenstein would say, no, there isn't any sound. There's nobody there to hear it. It's all dependent on us. That mathematics is a social activity. And when I was at Berkeley, and I was reading Wittgenstein, I began to have my own ideas about the foundations of mathematics. I wrote down one paper that I lost. I gave it to some people at Ohio State, some other people. But what it was a logical, I don't know, it was a skeptic view of Kleini's meta-mathematics. And I went through probably the first couple of chapters and tried to complain about everything he said. And I lent it to Gödel for a while he was still alive. And he took it and he looked at it, and I called him up on the phone and said, well, did you look at it?
So you met Gödel?
Yeah, I met him and I gave him this paper I wrote.
Do you still have the paper?
I don't know where it is, no.
Oh,
And nobody I gave it to knows where it is. They lost it, so I can't find it. So there's no, but I know the title of it, I remember that. I remember that.
Do you remember?
What it was about. I remember some things I said in there.
Can you reconstruct it?
It was about Kleini's book, Meta-Mathematics.
So was it a book review or was it?
This was just 30-something pages. And I never submitted. The name of the paper was Kleenex Logic. And it was meant that way. You know, that it was flimsy, that it wasn't substantial.
Did you send a copy to Klein?
No, I wasn't angry at Klein. I didn't want to, I wouldn't do that. I wouldn't have sent him a copy. But I asked her afterwards, well, what'd you think? Give me some feedback. And he said, it sounds like somebody trying as hard as they can to prove somebody wrong. I suppose that I'm to infer from that he did not think I had succeeded. But that's another story.
And what Gödel said?
That's what Gödel told me. He said, it sounds like somebody trying as hard as they can. And I didn't have the presence of mind to say, well, I guess you think I didn't succeed. I mean, it's pretty obvious he meant that. So he wasn't really positive toward that. Okay. About my
But you were also critiquing Gödel via Wittgenstein. Because Wittgenstein critiqued Gödel, and you agreed with Wittgenstein. So indirectly, did you also criticize Gödel? Maybe he took offense?
No, well, there's a guy named John Addison when I was at Berkeley. By the way, I started getting into all this at Berkeley again. When I was a senior, it just seemed like a bunch of nonsense to me. When I was at Berkeley, it started making sense. I liked to read it. It was funny. Guy had a lot of humor. But the idea I came up with, I would say something which I don't believe anymore. I said, mathematics is inconsistent. I remember at Berkeley, I go around telling people, mathematics is inconsistent, da, 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 da. And I walked into Tarski's office one day. And I said, this math is inconsistent, and so forth. And he said, okay, take an axiom system with an empty set of axioms. Now derive me a contradiction. I said, okay, you got me there. Okay, give me another one. He said, okay, take an axiom system with a set of axioms, not empty, but take an empty set of rules. Now derive me a contradiction. So you got me again. He said, n equals 1, n equals 2, get up. He proved that was all he wanted to discuss that. Now, the idea of math being inconsistent isn't really valid. It would be more valid to say that mathematics is too vague to ever be called consistent or inconsistent. It can't be. Why? Well, everybody might have heard of Bertrand Russell's statement about foundations. It's turtles all the way down. It's a turtle. Well, that's what I'm saying too. Let's suppose that somebody, they aren't. Oh, I don't like that color. Here's it right here. Let's say a mathematician who's starting a logical system. He's going to start from the very beginning. He's going to derive mathematics from logic, so a system of logic, a formal system. He's writing on the axioms. And then the student raises his hand and says, Professor, this axiom here, does it mean this, or does it mean that? And the professor says, obviously, Mr. Jones, you don't understand much, forget it, But the class kept importuning the professor to go ahead and decide what the ambiguity was. In other words, basically the guy who's putting the system up said only a fool would think it could mean that. But the student prevailed upon the class, and eventually he wrote down a subpart, a 1A, if you will. Another student raised his hand. Professor, did you mean this? Or did you mean that? And the same thing happened. And eventually the professor said, look, we can't even get started unless we all assume that these mean the same thing to all of us. It doesn't mean that you get out. We'll get rid of those people. We won't use them. But this is the idea of turtles all the way down. Where do you get started? How do you get started? Everybody knows that you have to somehow make peace with informal English when you're trying to define a formal system. Kleene says, these symbols are meaningless. Things like that, and so forth. But he puts, there's nothing with that, this is implies. But then when he introduces these meaningless symbols, he has to put a word next to it. Can't be meaningless. They aren't to him either. So the idea is you can't really get started anywhere logically. How do you get, what's a foundation? If you got a foundation, that's going to depend on something else, And yet, in spite of that, we're able to do mathematics, right? It doesn't interfere with us doing mathematics. You don't need to have a foundation for mathematics to do it. You just do it. Try to follow the rules as best you can. This is an extremely interesting statement by Wittgenstein. Logical inference is a transition that is justified if it follows a particular paradigm and whose rightness is not dependent upon anything else. The paradigm is some of the implication rules you might see in starting out a logical system. Okay, I read that. Okay. Now here's a guy who doesn't like Wittgenstein. I'm going to show you what he writes. R.L. Gödel. He's a logician. Everybody heard of him? Yeah. Okay. Wittgenstein, with remarkable insight, said in the early 30s that Gödel's result showed that the notion of a finite cardinal could not be expressed in an axiomatic system. A finite cardinal. And must necessarily take values other than natural numbers. A view which, following Skollin's 1934 publication, of which Wittgenstein was unaware, is now generally accepted. Skolin showed this that this was independent of Gödel's work. That idea that you were asking about, right? I may not have said it. There may have been some words I left out, I don't know, about the statement that any model, any valid model or whatever, in other words, it's probably a subset of all models, but this is what it basically, that's what Skolin basically said in 1934. These results are out of here, and of course they're surrounded before and after by other statements. But you can pretty much open that book anywhere and start reading. Everything I say amounts to this: that one can know a proof thoroughly and follow it step by step, and yet at the same time not understand what it was that was proved. We don't know that with calculus. So people either teach students to do all this, and they don't understand that. But there's a certain understanding in just doing, too. If you think you understand it, you can't do it. You can tell examples, and you don't really understand it either. And then he goes on with long stuff about what it means to understand. He's got his own ideas about that. That's not so obvious. He says, and if they demand a proof of consistency, because otherwise they would be in danger of falling into the bog at every step. What are they demanding? Well, they're demanding a kind of order. We're talking about consistency here. But was there no order before? Well, they're asking for an order which appeases them now. But are they not like small children that merely have to be lulled to sleep? His attitude toward consistency, basically, if it doesn't bother you, just forget it. If you had a calculus that was useful before, and all of a sudden somebody said, oh, no, it's inconsistent, that everything you did is useless? No. You can operate with inconsistent systems. In fact, there's something close to what you talked about. It's multi-value logic. I'm not sure what it is, but there's a system of logic that accepts inconsistency. You know what that is, offhand?
No, it's a multivariate logic.
I think it might be called
It's not just multivariate logic.
Paraconsistent logic?
What?
Paraconsistent logic?
Yes, absolutely. Thank you. There's so many arguments in that. Paraconsistent logic. That's right. It's not consistent. Something might be vaguely consistent and not consistent. Okay, so finished with that. Is a calculation an experiment? Is it an experiment for me to get out of bed in the morning? Said, but might it not be an experiment to show whether I have the strength to raise myself up after so and so many hours of sleep? And then, wow, one of the shortest talks. Now, I'm going to give you an idea by just randomly opening this.
And can you write the title of the book in the back?
Yes. Everybody refers to it as RFM. It stands for Remarks on the Foundations of Math. And I think it was published in the 40s. Wittgenstein didn't end up in math initially. It was always had a mathematical flavor. But one book that he wrote when he was very young, he totally repudiated. It was called the Tractatus. I spelled that right. It was an attempt in a much more concise way to do what Russell did, Whitehead and Russell. Make a foundation for all of math, actually all of reality. And then he totally repudiated that when he got older. And there's some people still who swear by that and haven't made the transition. And one of the most interesting books I read, I like the format of it. This is the title of the book. And what it consists of is, there were a whole bunch of little slips of paper in his drawer when he died. And he took all those and put them in a book. Sato. That means little pieces of paper. And that's a very interesting read. There's no plot there at all. There's no plot here either. I mean, you're not going to find him developing an idea like other philosophers do. And I think it's amazing that somebody could write stuff like this and still be very high up in the philosophical world and be very respected by philosophers and some mathematicians. I said something about John Addison, and I didn't finish my thoughts about John Addison at Berkeley. I said, what is this thing about sentencing unprovable, you know? I said, can't you have 2 or 3 sentences talking to each other? Saying things? He said, oh yeah. This is a book about whole communities of sentences talking to each other, yes. Didn't face him. I didn't write down what they were. I didn't try to read them. But it was interesting that he said that. So yeah, people have written papers about whole communities of sentences talking to each other. Okay. If I call a proof a model, a picture, then I must also be able to say this of a Russellian primitive proposition as the egg cell of a proof. That's not so interesting. I wish I could. The part about being like small children having to be lulled to sleep, I thought was one of the funniest things I've heard philosophers say. You worry about inconsistency? What's the big deal? You know, just relax. Good. Don't worry about it so much. It says, now can it be said that the concepts which mathematics produces are conveniences that essentially we could do without them? Says, first and foremost, the adoption of these concepts expresses the sure expectations of certain experience. We do not accept, for example, a multiplications not yielding the same result every time. I just read you something about that, right? Like, is it the hysterical feelings of a university person? Like, he thinks that's how they react to, it's inconsistent. And if you don't have a proof of consistency, can't you still deal with it? Sure. You can't prove arithmetic is consistent. You don't have a consistency proof of that within the system, but you still use it. Or if you don't need to have that surety, not necessary. let you look at those yourself. I wanted to end early anyway, and my son just had his wheelchair back today, being fixed after 6 months. He's so happy today. I want to go see that now. Now, do you have any questions?
Tommy's over? Okay.
Sure. I just want to use this opportunity to introduce you.
Oh, questions? Any questions?
Correct me if I'm wrong, but I think that at some point Quine had a theory, a calculus, with I think the iota operator or something, the unique x such as blah blah blah.
Absolutely.
Which then turned out to be inconsistent. And what happened is that people gave up on it, and then no one uses that.
Yeah, no, I'm not.
That's what would happen if whatever any of the formalisms that we use now was proved to be inconsistent. The reason that people go, for example,
I should mention
there are lots of things that people go on believing even though they cannot prove it. For instance, I'm talking to you because among other things I believe that you exist, although I cannot prove that. But I believe it. In the same way, I think most mathematicians believe that the usual formalisms that we work with are consistent.
Okay.
Although we know that we cannot prove it.
That's right.
But we go on, one of the reasons why we go on working with it is that we believe they are consistent.
Absolutely, that's true. And that's true about Quine too, yes. And Frege, I think, had a hole in his as well. That's who Wittgenstein was talking about first, was Frege. But let me continue on with this idea of Platonism, because Wittgenstein was not a Platonist. People try to classify him all these different ways, and they're finitist, and they don't fit. He doesn't really adhere to any particular religion in that way. But there's some thoughts recently that I've been reading about Platonism, very, very confusing. For example, Platonism means that you believe in an external mathematical reality. How do you communicate, you being a real person, with something abstract, an abstract idea? How can that happen? You're real. Math is abstract. In what sense are you actually dealing with it?
Abstract doesn't mean external. External to what? I don't know what you mean by external in this context.
I mean, you don't know what I'm talking. Okay, I haven't defined what I mean. What do you think? Like
words are abstract things, okay? Are abstract entities. They are not concrete sequences of letters. They are an abstraction that we made from certain sequences of utterances and so on.
Right.
But they are not external.
Well, if I'm trying to explain to somebody what a Platonist is, in other words, Platonists believe that you discover math.
Right.
That's Platonism.
Yes. Sure. Yes.
If you're not a Platonist, Wittgenstein believes you invented
everything.
You don't discover it. Yeah.
Including 1 + 1 = 2.
Yeah.
So it's only a social constant.
Well, the 1 + 1 = 2 comes about.
In different galaxies, 1 + 1 is 2.
If everybody doesn't get 2 when they add 1 + 1, then that shows the experiment comes out the other way. But I'm trying to talk about this, that if you believe you discover math, it's already there, outside of you. And no one thinks that the number 1 is concrete. You think all of math is abstract, pretty much, right?
Yeah, but that has nothing to do with being external to a world.
How do you communicate? How does a real being communicate with an abstract mathematical idea?
Well, we do it all the time.
I know, and it's a funny way to think about it.
I can know that there is a table here, or I can discover that there is a table in the other room. I don't have to communicate.
I think the idea is more if all life in the universe ended tomorrow, would 1 + 1 still equal 2?
Huh?
If all life in the universe ended tomorrow, if the universe ended tomorrow, would 1 + 1 still equal 2?
Sure.
No. I think mathematics is created by people.
And it was 1 + 1 was equal to 2 before at the time of the dinosaurs.
And so that's the sort of Platonist view, because it's external to your reality,
Because
it's external to your beliefs.
that collection of abstract objects does not have an existence in time. Things exist or don't exist.
And that's the Platonist stance. That's what it means to be sort of external to our existence.
You'd have to believe these things exist outside of people. But if mathematics is a social activity, which I don't think anybody would really argue against if you think about it, you have a hard time doing Platonism. It's just a social activity.
So Wittgenstein disagreed with Gödel? He did not?
No, he said that Gödel didn't understand what he was proving, that part of his theorem was a metaphysical statement. It wasn't a mathematical statement. And he objected to the extra baggage.
Because Gödel was a Platonist, and he disagreed with his
Oh, Gödel was a strong Platonist. In fact, stronger than anybody you might imagine. Stronger than Hilbert, all these. He was very, very Platonistic. Gödel was, and made no bones about it. But I think.
By the way, he also proved the existence of God.
Who?
Gödel.
Gödel. In his old age.
Yeah, he tried to at least.
Looking around for things to prove. Well, all I can say is if you won't be bored with, and if you ever pick up something by Wittgenstein, you won't be bored. I've never seen anybody so fundamental. I mean, the idea of what does it mean to follow a rule? You got to have some assent. You have to have a trainer. You have to have somebody being trained to add or multiply. All right.
Thanks a lot.